Hello, welcome to the video on factoring quadratic trinomials. This will be a lesson on this topic, and I got to say right from the beginning, this is an extremely important skill in algebra. Factoring trinomials comes up all the time, and you absolutely have to know how to do it. So if you pay attention, you'll have no problem understanding a couple of the most common techniques to factor these quadratic trinomials. Before you continue on, though, it's important that you already know how to factor out the greatest common factor and know how to multiply and work with polynomials. So if you're good in those areas, then you'll be ready for this lesson. But let's take a look at our objectives. First of all, we're going to learn how to factor quadratic trinomials, but they kind of come in two basic cases. Case 1 and case 2 is how I'm going to break them up. So we'll take a look at how to factor each case, and then the last thing is we'll determine if a quadratic trinomial is prime, meaning that it cannot be factored. So let's get right to it. We've got a lot to cover here. So you can see here I have a particular quadratic trinomial. So what makes it quadratic? Okay, well, trinomial, first of all, is a polynomial with three terms. So we have 1, 2, 3 terms. Well, the quadratic part comes in because the highest power, or the degree, is 2. Okay, so when you have a trinomial where the highest power is to the second power, you have a quadratic trinomial. So we're looking at factoring these quadratic trinomials. Now, when you can see here, I've already factored out this particular quadratic trinomial, and we get x squared minus x minus 6, that quadratic trinomial, is equal to the product of these two factors here, okay? X plus 2 times x minus 3. So if you took those two binomials and you multiplied them together, you'd see you'd get back to this trinomial here. So the key here, or the question is, well, what if I didn't know these factors, okay? What if I was just given this quadratic trinomial and I was asked to factor it? In other words, find two things such that when you multiply them together, you get back to that original polynomial, okay? Specifically, these quadratic trinomials. So that's the whole objective, the whole purpose of this lesson is to figure out how to do that. And a lot to talk about, so let's get right into these different cases I talked about. Two basic cases when we look at factoring these trinomials. So the case 1 and case 2, so maybe you could take a look at it. I'm going to give you a bit of a hint. What distinguishes between the two cases is the leading term. Now, if you remember, the leading term is the term when these polynomials are written in standard form. In other words, highest to lowest power. Okay, and they're quadratic, so the highest power is to the power 2. So what distinguishes between these case 1 and case 2? Well, I'm going to cut right to the chase. Case 1 is where you have these what we call 1x squared situations, where the leading term, the leading coefficient is 1 and always 1. Okay, so you have 1x squared minus 5x plus 6. You might have another one. So let's say x squared minus 3x plus 1, or x squared plus 7x minus 10. Okay, these are all examples of these quadratic trinomials that would fall into the case 1 because they're 1x squared. Well, if it's not 1x squared, it falls into the case 2 category. So here, for example, we have this particular trinomial that has a number other than 1 as its leading coefficient. So we have a 3x squared situation. You're going to use two different methods. They're kind of similar, but there is some differences to factor these different cases. All right. And right now, I'll just tell you, case 1 is really easy. Case 2 is just a bit more involved. So let's get to it. And by the way, I cannot stress to you enough the importance of looking at these example sets also, practicing as much as you can to get really good at this. All right, so let's take a look at the case 1, the easy part. Let's get that out of the way. All right, so to factor these 1x squared trinomials, first thing is this. I'm going to kind of lay it out in steps for you, but I want to just show you, and then you can write the steps down later. Okay. First thing is you got to make sure that these trinomials are in standard form. Okay, meaning that you have the highest to lowest power. Okay, you have x squared minus, and the x part and then a number. Okay, x squared, the x or the middle term, and then the numbers. This is standard form. All right, so once it's written in standard form, here's what I want you to do. Okay, I want you to take that 1 here, and I want you to multiply it by the last number, which is the constant. Okay, so what do you get there? 1 times -8 is -8. Okay, so you have -8. Now, what I'd like you to do is list the factors of -8. And the way you're going to do that is this. So let's see here. 1 times 8. 1 times 8. So -1 times +8 will give you a -8. Or 1 times a -8 will get you a -8. 2 times 4. Let's give ourselves some more room here. Well, if I had a -2 times 4, that gives me -8. And 2 times -4 gives me -8. So those are all the different possibilities to get -8. All right. Now, the key here is this. After you list all the factors, all right, you have to pick the factors such that when you add up these individual factors, you're going to get this number, this middle number here, -2. So which one of these pairs of factors adds up to -2? Well, it's this pair, right? Okay, because 2 plus -4 gives you -2. All right, so what does that mean? We're going to do a ton of more practice on this. If you're a little confused, we're going to do another one, and of course, you might want to watch a lesson again. Well, these quadratic trinomials always break down into 2 binomials. And I'll tell you right now, these binomials both have an x and x right here in this first location. Now the key is this, or the rest of what we're trying to do is trying to figure out what goes here, okay, to finish these factors up. Well, we just found out what goes there, right? One of these binomials, it doesn't make a difference which one is going to have a +2, right? This is this one, and the other one's going to have a -4, and you're done. Simple as that. So let's double check this. Let's make sure that x plus 2 times x minus 4 gets us back to our original answer. So let's use the FOIL method. X times x, x squared, x times -4, -4x, 2 times x, 2x, and 2 times -4, -8. So when we add up like terms, we get x squared minus 2x minus 8. All right, and that's what we started off with. Okay, so it does work, and it'll work every time, but you just have to, just take some practice, and after a while, it won't seem nearly as hard. All right, so if it seems hard, well, that's kind of natural because it's new. All right, let's try this one now. Okay, we're going to take 1, and we're going to multiply that by 24. All right, so 1 times 24 is, of course, 24. Now let's list the factors of a +24. So that's 1 and 24, or -1 times a -24. Let's see here, 6 times 4, or 6 times 4. Now I like to kind of put 2 negatives there. 3 times 8, -3 times -8. Oops, -8. There we go. Okay, so which one of these pairs of factors are going to add up to what? Okay, what's the magic number that we're looking for? 11. It's that middle term. So which one of those factors, pairs of factors, add up to a +11? Well, there you go. Okay, this 3 and the 8. So this thing will break down, this trinomial. Remember this, the 1x squared is always have an x and an x here. That's always the situation. And if they factor, you'll see their the rest of the binomials listed here. Okay, so here you're going to put a +3. If you want to put it in the first one, it doesn't make a difference if you put it in the second one. And a +8. And there you go. Those are the factors of that quadratic trinomial. Okay, so that was the easy part. All right, that's case 1. So now let's get into case 2 here. Okay, case 2, I'm going to show you what I think is the best way for students. If they get lost, this is kind of a step-by-step way of doing these problems. And then we'll get into another method called kind of the guess and check. I'll tell you right now, I would just kind of get used to one method, pick one that you'll like, and get good at it. But I do think it's important that you see both processes. All right, case 2, first method. What you're going to do is going to do something very similar to what we're doing in case 1. We're going to take, first of all, we're going to make sure that the polynomials, the trinomials, are written in standard form. You can see here that they are. I'm going to take that first coefficient, that leading coefficient, and we're going to multiply it by that last number. So 2 times 3 is 6. Now we're going to go through that factoring situation, okay, and we are going to be looking for this middle number. So this is very similar to what we were doing before. So let's go through that. 1 and 6, negative 1, negative 6, 2 and 3, and negative 2 and negative 3. Okay, so which one of these pair of factors add up to that negative 5? Well, it's these here. Okay, now this is where things start getting to be a bit different than what we were talking about last time. What we're going to do now is we're going to write our original trinomial, but we're going to write it this way. 2x squared. Now here's the kicker. We're supposed to write a negative 5x. Well, I'm going to write negative 5x there because I don't want to change the problem, but I'm going to do this using these factors. I'm going to write negative 5x as negative 2x minus a 3x, because when you add those two up, don't you get negative 5x? Okay, so let's write that middle term as negative 2x minus 3x, and of course we have this last, the constant part of our trinomial, so we'll write that in next. Okay, so I hope you're still with me. Okay, we're getting there. We're more than halfway there. Now, here's what you're going to do next. What you're going to do is you're going to separate what you just wrote into two kind of groups. This is going to be the first group, the first two terms, and these last two terms will be the second group. Now, in those two individual groups, I want you to factor out the GCF, the greatest common factor. All right, so let's take a look at the first group. You can see here that 2x will be the greatest common factors, and I can write this right here as 2x times x minus 1. All right, so if you don't understand what I did, you need to go back and take a look at how to factor out the GCF. All right, now let's go ahead and do this second one here. I can write this as negative 3 times x minus 1. All right, see how that works? So if I distribute this negative 3, I'll get back to negative 3x plus 3. All right, just about there, so stick with me. Now, look what you have in common. You have these two factors in common. So we're going to factor those out, all right? And if you're not sure what I'm talking about, just kind of follow the pattern. What you're going to do, you're going to factor an x minus 1 out. Every time you do this, you should get the same binomial, the exact same binomial. If you didn't, you did something wrong. So what you're going to do is you're going to factor that binomial out, and you're going to write whatever is left in the other binomial, and that is, let's use another color here, 2x and this minus 3. That's what goes in the other binomial, and you're done. Okay, so now we're done. But let's make sure that we can see, kind of prove to ourselves that this works. All right, this is the answer. Okay, when you multiply those two together, you should get this. So let's do that. X times 2x is 2x squared. Negative 1 times 2x is negative 2x. Negative 1 times negative 3 is negative 3. And x times negative 3 is negative 3x. Okay, so you can see here, when you add these up, in fact, you'll get back to 2x squared minus 5x minus 3. Okay, so I hope you're not discouraged. Okay, if this is the first time doing this, this is a lot. But I'll tell you right now, you'll be a master at this. It just takes some effort, takes some practice. All right, let's go ahead and do another one using this first method. And I'm going to be using this method a lot in the example sets, okay? Because it's a step-by-step method. Let's pick it up now. So we got our trinomial written in standard form. So it's going to be the first times the last, and we get negative 18. All right, so I'm looking for the factors of negative 18 that will add up to 7. All right, so if you already know what those are, you can just kind of jump right to it. So that'll be 2 times negative 9, correct? 2 times negative 9? Nope, that's not it actually. Negative 2 times 9. Excuse me. All right, these two add up to this positive 7. Because that's the middle term. That's the middle coefficient that I need to match things up. So these are going to be my magic numbers that I'm going to use to help me factor this trinomial. All right, so now let's rewrite the trinomial. This time I'm going to write 7x as negative 2x plus 9x. That's the way I'm going to write that. So let's go and write it that way. Minus 2x plus 9x minus 6. All right, so we have our first group here and our second group here. So let's go ahead and factor out the GCF in each. So we got x times 3x minus 2. Now, if all goes right, see this 3x minus 2? That should show up also when you factor this second group. That's key. All right, so let's see how this will work out. So we can get a 3 times 3x minus 2, and in fact it worked out perfectly. Okay, so now you can see that you have your 3x minus 2. That's in common, so we'll write one of those. 3x minus 2, and then x plus 3 is what's left. Okay? All right, so that's one method. Now let's take a look at the second method. I told you this was going to be a long video, and you know, you might want to watch it a couple times. So if you like that method, maybe you go right off to the races and start doing the example problems. If you want to see another way of doing this, I'll show you another way. Okay, the second way of doing this is completely different than the first way, but it's just as good. What we're going to do is we know that these trinomials break up into two binomials. Okay, they factor if they're factorable. Sometimes they're not. Well, what we're going to do here in this second method is we're going to look at the first term, okay, 2x squared, and we're going to factor the first term in these spots. We're going to put the factors of the first term in those spots. And then we're going to put some factors of that last number, the constant, in these spots. Okay? And what we're going to do is to try to form two binomials such that when you multiply them, you'll get back to here. So this is how this works. You're always going to have, here you can see that 2 breaks down as 2 times 1. And you always got to put an x in each one of these binomials. All right, so that's something that you always have to do. Now, the key is you have to look for factors of 3. Well, that's pretty straightforward here. Factors of 3 are 3 and 1, okay, or 1 and 3. Now, you're not quite sure what position to put these factors in, and that's where the guess and check part comes into play. All right, but here's the kicker on this. I kind of call it the double smiley situation. You want to look at this times this, okay, the inners and the outers. All right, so what's 3 times x? It's 3x, right? And what's 2x times 1? It's 2x. Now, what you're trying to do is you're trying to get these two terms to add up to this term. All right, so I have a 3x and a 2x. If I add them up, I got positive 5x, but that's not what I want. I want a negative 5x. So I need both of these to be negative, right? Well, the only way to do that is to put a minus sign here and a minus sign there. Okay? And when I've done that, I can get my negative 3x and my negative 2x. All right? But let's just make sure that, now if you got this middle term, that's negative 5x, let's just make sure that we, in fact, have the right factors. You always have to check yourself here. So 2x minus 3 times 1x, or x minus 1. Let's make sure it ends up to be the original. We get 2x squared, 2x minus 1 minus 2x, negative 3 times this 1x is negative 3x. Negative 3 times 1 is a positive 3. So you see that this will, in fact, work out. You add your like terms, so we're good. All right, we got the right factors. So let's do the same problem now. Okay, we're going to take a look at this. We've seen this problem before, but now we're going to do it with the second method. So we need to take 3x squared, put its factors here, and then we need to take this negative 6 now and put its factors here. And then we'll take a look at the double smiley and try to get something that adds up to this positive 7x, and we should be good. All right, so I'm just going to put a 3x and an x. Remember, each one of these binomials has to have one of the x's in them. All right, so let's see here. How about 2 and 3? Okay, our factors of 6. I'll worry about the negative part when I'm done. Let's just get these things to add up to 7, the double smiley. So I got 2x and I got 9x. Wow. Let's see here. Between those two terms that we got, can you get these to add up to 7 some way? How can I get a positive 7x out of these two terms? I think we got lucky here. If this was a negative 2x and this was a positive 9x, right? These two terms would add up to a positive 7x. And that's what I want. So I got to form a negative 2x. Now the only way that's going to happen is I got to put a negative here. And I want to keep my positive 9x, so I got to put a plus here. All right, so hopefully those are the right factors. So let's go ahead and check it. I have 3x minus 2 times x plus 3. I get 3x squared. 3x here is going to be positive 9x. This will be a negative 2x, and this will be a negative 6. So you can see here, when I'm all said and done, in fact, they are the correct factors. I get back to the original answer. All right, so two different methods. A lot going on in this video. You know, try both methods. See which one you like. If this is new to you, it's going to take a little bit of time, but you can definitely do it. All right, let's just kind of do one more thing before we finish the video. How do you know if a trinomial can be factored or not? Well, a little trick is this. You can take a look at what we call the discriminant. Standard form. Okay, each one of these coefficients are assigned a variable to them. Okay, and usually it's A, B, and C. Okay, so this middle term's coefficient here, in this case it's 3, is going to be B. The last, or the constant number, is going to be C, and then the leading coefficient is going to be A. So let's take a look at what b squared minus 4ac is in this particular problem. So b squared minus 4ac, you've got to remember that. It's called the discriminant in algebra, and you'll see why later on when you study quadratic equations. So b squared is going to be 3 squared minus 4 times a is 2, and c is negative 6. All right, so we're going to get 9 minus, or let's see here, this would be plus, negative 8 times negative 6. All right, so you might want to go ahead and finish that up. So what do you get when you have 9 plus negative 8 times negative 6? Okay, you have 48 plus 9, all right, is 57. All right, so 57. Now this number, whoops, 57. What do we just do, or why are we doing it? Well, if this number here, if you can take the square root of that number and it's a perfect square, that trinomial can be factored. All right, I'll tell you right now, this particular trinomial cannot be factored. Let's make sure we understand what a perfect square is. Perfect square is a number like 4, 16, 9 is a perfect square, 25, 36, 49, 64. Okay, all of these numbers, when you take the square root of them, you get a nice whole number, nice integer. Okay, here I'm going to get some sort of decimal. So if the b squared minus 4ac is not one of these perfect squares, and I mean, like for example, let's see here, 144 is a perfect square, etc. Okay, any perfect square. If you do have a perfect square, it can be factored. If it's not, it can. Okay, so let's get to it. Let's wrap it up. So in review, remember factoring trinomials is a very important skill, and I applaud you for sticking with me in this long lesson, but it's absolute critical lesson. You might want to watch it a couple times or maybe fast forward to the parts that you want to review. There's two basic cases. Remember, there's the 1x squared situation, and then there's the trinomials where you might have, like, say, 3x squared as your leading term. So you have to do two different things. In these second case situations, like this 3x squared situation, there was two methods, okay? And it's really up to you which one you want to master. And then we talked about that prime trinomials, and we discussed how you can determine that b squared minus 4ac. We talked about how prime trinomials cannot be factors, so you'll never be able to break up, for example, this particular trinomial. You just won't find two binomials that you can multiply together and get back to that original quadratic trinomial. All right, so good luck. Don't be discouraged. I'm really proud of you for getting through this lesson, and I hope to see you in the example sets. Really important. So let's get it on over there and master this skill.